How would you like to prove that 2 is equal to 1? Well, that's exactly what we're going to do today. We're going to start off with a normal algebraic equation with a and b. We're saying that a is equal to b, and we're just creating these variables, so this is perfectly true. And we're saying that neither of these are equal to 0 because we're going to divide by a or b at some point in this proof. We don't want a division by 0 error. So, with that out of the way, let's start manipulating this equation. Given the properties of equality, we can multiply both sides by a. We get a squared is equal to ab. What next? Well, we can add a squared to both sides, again not violating any properties of equality. We get 2a squared is equal to a squared plus ab. One last thing, let's subtract 2ab from both sides. This just looks like we're randomly doing stuff to this equation, but actually it's going to come useful later on in this proof. So we're going to say that 2a squared minus 2ab is equal to a squared, and notice this is just plus ab minus 2ab, so you can combine that to get minus ab. So moving back up here so I have more space, let's factor out stuff from each side of the equation. We can factor out a 2 from the first side, and we can also factor out an a. You get 2 times a times, well, 2a squared divided by 2a is a, and 2ab divided by 2a is b. So we get 2a times a minus b is equal to, and if we do the same process here, we get a times a minus b. Maybe you see where I'm going with this. We can cancel off some terms, and we can cancel off a and a minus b until we get 2 is equal to 1. As promised, we have proved that 2 is equal to 1. Now, if you saw the title and saw 2 is equal to 1, you're probably thinking that this is a false proof of some kind. Indeed, it is false. I did a similar proof, a geometric proof, earlier in my specials channel, in which I proved something to be false. But the proof looked normal, but there was just one error. See if you can find this error. Now, I'll explain it. If you want, you can pause the video and try to catch the error yourself. All the steps are on here. But the error is actually in the last step. This is not a valid equation because this is the last valid equation that we created. Why is this not valid? Well, in this equation, we canceled off a and we canceled off a minus b. The problem was canceling off a minus b. That's effectively dividing both sides by a minus b. Now, you might be thinking, that's why we made the disclaimer in the first place. Actually, no. We just made the disclaimer to make sure that a and b are not 0. But since we have a is equal to b, we can subtract both sides, b from both sides basically, and we get a minus b is equal to 0. Which literally contradicts this statement, because we said a minus b, we're dividing both sides by a minus b, we are basically dividing both sides by 0. So this is the final possible equation that we can get. We can't simplify this, into 2 is equal to 1, because a minus b is equal to 0. And why this equation itself holds true is because a minus b is equal to 0. So by the zero product property, we get 0 is equal to 0, which is a true statement. But we cannot divide by a minus b, because that would give us a division by 0 error. In the start, I said a is equal to b, which is not equal to 0, just to make you think that it would not be a division by 0 error. So it's a bit tricky in that sense, but I hope you enjoyed this video. If you like more proofs like this, I'll continue on my specials channel with these kind of proofs. I enjoy them too, and I'll see you in our next special. See you later.